Okay, today we will be talking about capacitance and capacitors in general. But first, before we even move forward with capacitors, what are they? شو معناتها capacitance؟ we used to look at resistors, we used to look at a circuit. يكون عندنا voltage source، يكون عندنا resistor. كذي الريزستور هذا شو يسوي؟ This resistor we have this equation which is V equal IR. And then this resistor basically slows down the current. You can think of it that way. You can feel a polarization. You have current going through. You have the voltage going through it. And the voltage basically is increasing as your resistance is, or your current, I should say, is increasing as resistance is decreasing for the same voltage source. فكل ما كان أكثر الريزستنس عندكم في الواير كل ما you're reducing the total current that is flowing through your entire circuit. But what about a capacitor? What does a capacitor do? So first of all, a capacitor, the way they denote it in a circuit is in two ways. They either have it as somewhat like a battery, but both of them being equal size, something like this, or it will be something like this, the letter C. And this basically shows the polarities of the capacitance. Okay. Um, so yeah, this basically shows the polarities where this is going to be your positive side and this is going to be your negative side for a capacitor. But before even going into the circuit and all of that and going into details on how to solve for a capacitor in a circuit, what is a capacitor? So a capacitor is basically two pieces of metal, thin plates, زين يكونون كذي. All right, these are basically plates. يعني they're a full aluminum plate. All right, يعني as if they're two aluminum plates like this that are usually of the same size. All right, that in between them here there is a space, a distance. All right, this distance. This is known as the distance usually between the plates, and these are known as plates. And this as a whole is called a capacitor. But what happens, يعني why is this a capacitor? So these are two metal plates. Then these two are made out of metal, and what's in between them is usually called a dielectric or a dielectric material. This dielectric material is basically holding, يعني it's a material, or sometimes air, or sometimes wax, or sometimes it's a specific type of material that usually is somewhat of an insulating kind of thing that will slow down the current in between these two metals, or sometimes even completely preventing it. Okay, I'm not going to go too much into detail about this, but I want you guys to understand how a capacitor works. فإذا عندنا إحنا هني الحين we connect this capacitor to a voltage source like this. Once you connect it to a voltage source like this will be the positive side and negative side of your capacitor. And the capacitor itself usually has its own polarization usually. And the connection should always be in this way, where the positive side of the capacitor should be to the positive side of the battery and the negative to the negative. Otherwise, current will be flowing in the opposite direction and it could cause your capacitor to explode. All right. And I will go into the detail about that later on. But for now, what is happening? So هني, when you are having a current that is flowing through this, you are making this side basically positively charged. All right. And this side is becoming negatively charged. All right. So there's going to be something known as an electrostatic force, اللي هو the force of attraction بين الpositive والminus. You guys know that plus is attracted to minus. زين يعني there's going to be a force that is making these attract and go towards each other. So this force, this electrostatic force, is what basically allows there to be a force of attraction in between these two. And this is the storing of how they store the current, or they store the voltage, I should say, in between these two metals. So all that is happening is you are basically making one side positive and the other side negative. وبعدين بيكون عندكم an electrostatic force in between. The strength of this, I haven't seen you guys use this equation, but the strength of this force, or F electrostatic, is going to be the voltage that you have from the battery over here divided by the distance between these two plates. So this distance over here, this is the strength of the force. فمعناته as the closer these two are together, معناته the smaller the distance, the larger the force, obviously. And as well, if the voltage is very high, then the force is also going to be high, making it store or have a larger electrostatic field in between. So this is just the basic concept of what a capacitor is. You don't need to know too much about this theory. What you guys need to know is a capacitor is usually known, or the capacitance that is stored in a capacitor is known as the Q over V, where Q is your coulombs, which is the unit of charge, and then divided by your voltage, or the voltage of the capacitor itself. And this is your capacitance. This is the most important equation you guys need to know. This is very similar to the idea of V equal IR, but for capacitors, all right? So if you rearrange this, you can say that Q is equal to your capacitance times your voltage, and this is very, very similar to V equal IR equation, just in theory, يعني. It is the same idea because you will be utilizing it in almost the same way when it comes to capacitors. Q, like I said, this is coulombs. The unit of it is coulombs. All right. So this is in coulombs. The capacitor, this is in a unit known as farads. All right. And voltage, you all know, is in volts. All right. So coulombs, farads, and volts. Okay. This is what you just need to know about capacitors when it comes to in a circuit. It basically means that the capacitance of a capacitor, all right, is known as the amount of charge or amount of charge that is flowing through the capacitor itself per 1 unit of voltage. This is what is meant by a capacitor. Okay. Now, like I said earlier, when you have a voltage source in a capacitor, this basically means that you are charging the capacitor and it is storing a specific amount of voltage inside. Yani it basically will become charged up and then it can be used as a battery. So this is, you can think of it as a temporary battery. This is what a capacitor is. So when it's connected to a voltage source, it is going to charge up and then it will reach a limit بما معناه. And we will look at that later on when we look at RC circuits, where خلاص all the positive and negative, يعني this is fully positively charged بما معناه and this is fully negatively charged, and it will stop allowing current to flow through it and it will act like an open circuit. لأن this will be basically fully charged. And then you can use this capacitor, and then you can use the capacitor. So this is the positive end and the negative end, and you will be able to use it as a battery itself. And let's say, يعني, for example, here we have a light bulb, all right? And it will be providing current from your positive side to the negative side once connected, and it will act as your voltage source throughout this circuit. Okay, and this is known as discharging your capacitor. Okay, this is just a little bit of theory. We're going to look at this a bit more in detail when we look at RC circuit. But before that, let's look at the properties of a capacitor. So remember that a capacitor has two metal plates. That's the first thing. And it has the dielectric, which is the insulation in between. All right, sometimes known as the dielectric insulator. Okay. So if I draw this, and if I draw the plates, I'll try to be as neat as I can. So this is what it will kind of look like. Okay. فعندكم two plates, all right? Usually these plates have the same area, all right? The area of these two plates are the same. بالمنطق, as area is increasing, all right? As area is increasing, the value of your capacitor or capacitance will also increase. And capacitance is basically how much it can store, how much voltage it can store, all right? So capacitance بما معناه has is how much the capacitor can be charged. All right, can be charged. This is what capacitance is. When we're talking about capacitance, يعني we're talking about how much the capacitor can charge, can hold or have charge of a specific amount of voltage. تمام? So the capacitor itself, it has an area. Okay, so you're gonna have an area on the capacitor of these sheets, of these metal sheets, and this area كل ما كبرنا في الاريا أكثر, as area is increasing, the value of your capacitor will also, or the capacitance, يعني how much you can store, will increase, because here you have your positive side and your negative side on the other side over here. The more area you have, the larger the size will be. يعني when you make it much larger, you're going to have much more positively charged areas and much more negatively charged areas on the other side. So there will be more forces or more electrostatic force, meaning there is more possibility of storage. Okay. Another thing is the distance in between these two هني. All right, so the distance between these two plates, this also plays a major role in your capacitance. As you increase your distance, بما معناه, the further away you remove this plate from that plate, the larger or the less amount of field you will be able to have. معناته your capacitance is gonna reduce. لأن بالمنطق إذا إحنا الحين حاطين البليتس هني, right, والبليت الثاني خليناه all the way over here. Okay, the distance this has to cover the electrostatic force is going to be too large, so there's going to be a weak attraction force between this plate and this plate. Therefore, يعني when you're increasing your distance over here, كل ما قاعدين تكبرون فيه, كل ما there will be less possibility of storing more charge, لأن the field itself that you are generating is going to be very weak. Okay? The last thing we didn't talk about is what is in between these two plates. So like I said earlier, so now we have these two plates. These both have a specific area. We talked about that. And we talked about the distance in between them. And we saw the relationship. The last thing that we have is this middle part. What is inside this area? It could be air, it could be water, which I don't recommend, but technically it could be شو يسمونه بعد, it could be wax, usually what is used. It could be ceramic, which technically would never be used because it's a strong insulator. But how do you know how strong this insulation is? This is based on the concept known as permittivity. All right, so there's something called E, which is your permittivity. All right, what does permittivity is? بما معناه, it gives permission. If you think about it, this is where the word comes from. All right, permittivity. Permittivity meaning it permits the transfer from your plus to your minus. This is what it means. يعني it allows transfer going from here to here of your electrostatic field, all right, or your electrostatic force. بما معناه, it makes sure that your electric field has an allowance يعني to move from one point to another. But the material inside this E depends on the material of dielectric, or better yet, not material, and usually it's not a material, but the nature of your dielectric, whether it is air, whether it is Teflon, whether it is wax, whether it's paper, whether it's a ruby مثلا, يعني a diamond, it does whatever it is, all right? It always depends on the type of material in between, and capacitors are usually designed with a specific material depending on how much charge you want to store it. Then, for example, if you want to reduce the size, reduce the area, you're going to have to mess around with the material inside, and you're going to have to mess around with the diameter or the distance between the plates, because you don't want them to be touching, but at the same time, you don't want the distance to be too far off. And this permittivity, the way it is the permittivity for vacuum. What does vacuum mean? Vacuum means empty space. Then the permittivity of vacuum, all right, or I should say the relative permittivity of vacuum is equal to 1. زين 1 meaning ان it is exactly 1, which is there is no value of it بما معناته there is a 1-to-1 ratio between the plus and minus يعني the full force is being applied. There is nothing reducing the force that is being applied between these two capacitors. All right, this is the relative permittivity of vacuum. When we say ER, we are talking about the relative permittivity. Insane. For vacuum, it is equal to 1, meaning that you are fully transferring whatever the electrostatic force is here. لأن there is completely empty space in between them, not air between them. مو بأنه هواء، لا، it's inside a vacuum. بما معناه there is no gas particles or any liquid particles or any sort of particles in between these two plates. إنزين. This relation comes from, how did I find my relative permittivity? This relation comes from something known as the dielectric constant, which is known as your E over ER, or actually E0 over your ER. All right. This is a dielectric constant where E0 is your permittivity of free space, which is a constant based on the vacuum. Then a free space meaning vacuum, and this value is a constant that does not change, which is 8.854 times 10 to the power of negative 12, divided by the unit of this is farads per meter, which we will see how we got this unit itself. This is a constant, yani this has came out from experimentation and all of that, just like other constants you have learned before, just like gravity is 9.81, same thing. This is your constant, and this is your relative permittivity. All right. So again, this is your permittivity. Actually, this is the opposite way around. My bad. Your E0 has to be down, and your relative permittivity is going to be up. Okay. So this is what it is. Your ER over E0. E0 being your free space, permittivity of free space, which is your E0, the constant that you have, and ER being the relative permittivity depending on the material that you have. All right. This is known as the dielectric constant. I haven't seen you guys use this a lot, but this is an important concept when it comes to capacitors. What you guys usually use is directly your ER and E0. So in other words, E0 is the free space, اللي هو هذا الvalue. Well, E relative is basically you're dividing this by this to see the ratio of ER to E0. That's it. عشان تعرفون this material compared to the permittivity of free space, what it means. Instead of going more into theory about this, what does all of this have to do with a capacitor? So again, like I said, if we have a vacuum amount over here, زين, a vacuum amount, معناته there is nothing that is stopping this electrostatic force. But if we have a specific item inside of here, it will cause it will slow down, or it will affect the electrical field that is occurring between these two sides of the capacitor. All you guys need to know, this is actually going to be K instead of RER. All you guys need to know is this equation, اللي هو C, which is your capacitance, is going to be equal to your your permittivity of free space. Excuse me. Your permittivity of free space times your permittivity or relative permittivity times the area divided by D. All right. You don't need to know too much about the concepts over here and go into too much theory. What you need to understand is your capacitance as these values increase. So we know that this is a constant, so it will never increase. But if your permittivity is being increased, your relative permittivity is increased, your C will increase with it. If your area is being increased, your C will increase with it. But if your distance is being increased, your capacitance will decrease instead. based on the concepts that we have seen before. All right. So this is the formula for capacitance of a capacitor, depending on the design of the capacitor, depending on the dielectric in the middle. So again, this is just the dielectric. All right, and these are your two metal plates. You have A, which is your area of the plates, your dielectric, which will determine your permittivity, which is your E relative. Okay, this is how you get it. And your E relative, you just get this from a table, or the value will be given to you. وين راح التable? This is your table over here. So for different random materials, you're going to have different relative permittivities. All right. So for example, like I said, for vacuum, it's just going to be 1. For air, it is going to be 1.0006. Teflon, it's going to be 2. If you notice air, it is the closest to vacuum basically, لأن ما في يعني air isn't going to be stopping an electric field. But what I want you guys to look at, for example, is ceramic is a very, very high relative permittivity constant. لأن it is extremely insulating, all right? So that's why it is a very high value. But yeah, basically you'll get the value for your ER, and E0 is a constant, which is always going to be given. E0 is simply just 8.854 times 10 to the power minus 12 F over M. All right, and we will talk about the unit in a bit. Relative permittivity, since it's a relative value, it has no unit. A is your area. Your area is going to be in meters, and your distance is going to be in meters. Area is meters squared, and distance is in meters. And your capacitance is in farads, so you can get your final value. If you notice, if you rearrange this equation, since relative permittivity has no unit, this is m squared over m. So this is F is equal to, and let's not look at E0 for now. We'll keep it as E0. ER, there is no unit. M squared over M. معناته F is equal to E0M. معناته E0 is farads over M. This is why this is the unit, because it is a constant. يعني this constant came from these values, not the other way around. That's why the unit of your permittivity, your free permittivity, I should say, permittivity of free space is F over M. And this equation is what you will be using when you want to find your capacitance given the material itself, يعني given the design of your capacitor. Is this clear so far? أعرف وايد هرهرت عن الموضوع, but what you guys really just need to know is this part over here. You need to know that this equation, why we use it, how we use it, why it is in this form, and you will understand how to apply it given area, given diameter, or distance, not diameter, sorry. Your E0 you will always have from yourself. It's actually epsilon 0, but I called it E0. And how they will affect your capacitance as a whole. All right. So moving on from this point, there's one more thing you need to know about capacitors. It is, so you know capacitors store. When you store something, that's basically energy storage. And how do you know how much energy is being stored? Very simply, energy is equal to half CV squared. And that's it. This is the only formula you need to know. If you're trying to find the energy being stored by a capacitor, this is what you will be using. Obviously, you can manipulate the equation that we have saw earlier, which is CV. All right, Q equal CV. Your charge is equal to the capacitance times the voltage. If you plug it in here in different ways, just like the power equation for V equal IR, you're going to get these two other equations as well, half Q squared over C. Okay, this is already given in the formula sheet, but all you have to do is just plug in values and you will be finding all your the energy that is required or that is being stored. تمام. القوانين كلها بيكون عندكم إياها. إنزين, don't worry, you're going to have this equation. Where is it? This equation is going to be given. This equation is going to be given. It might be given in this form though. C is equal to Q over V. But you guys at this point, at this level, you should know how to move this and to change this into this. And they will give you this energy equation as well. All right. Let's actually look at some examples so that you understand what I'm talking about this entire time. and how you might have to solve for something like this. So here it says the following parameters are given. معطينكم ال E0. The area of the plate is area is equal to 1000 millimeters squared. The first thing you have to do here is convert into meters squared. This is usually the trick when it comes to this. You have to convert this into meters. How do you do that? You are going to multiply up and down. What do we want it in? Meters. What do you want to change it from? Millimeters. All right. 1 meter has 1000 millimeters. صح? However, this is meters to millimeters. We want it squared. So we have to square everything up and down so we can get it in squared. All right. So it is going to be here. If you notice, the millimeters squared will cancel with the millimeters squared. بيبقى لكم 1 sorry بيبقى لكم 1000 times 1 meter squared على 1000 squared بما معناه يعني 10 to the power of 6. So the area is equal to 1000 over 1000 squared is basically 1 over 1000 or 0.001 meter squared. All right. So make sure you know how to do this conversion. هذا أهم شيء. This is what they're going to be testing you on most of the time. لأن معطيكم كل equations. What they need you guys to understand is يكون عندكم meters, not at millimeters. So this was for the area. Same thing again over here. For your distance between the plates D is equal to 2 millimeters. You convert that into meters. It's 2 times 10 to the negative 3, or you can say 0.002 meters. Okay. Relative permittivity is given. So you have your relative permittivity over here, which is good. All right. So ER is equal to 5.5. It is unitless. ما يكون في unit لأن it's a relative value. وآخر شيء معطينكم الفولتج is 20 volts. V is equal to 20 volts. So what does the question want? The capacitance value. Very simply, C is equal to, the equation is already over here. You just plug in your values. So E0 is 8.854 times 10 to the negative 12 times ER. So E0 is done. ER is 5.5 times your area. What is your area given here? It is 0.001. So it's 0.001 times or divided by your distance in between, which is 0.002. And you will get your value for capacitance. So if I just put this in the calculator very quickly, 8.854 times 10 to the negative 12 times 5.5 times 0.001 over 0.002. This will give me my capacitance is 2.43. Express your answer up to 2 decimal places. طلع لي 2.3243, so I'll keep it this way, times 10 to the minus 11. Now, another thing you guys need to know when it comes to capacitors. Capacitors, the value of capacitance is always very low. So this is in farads طبعا, all right? So usually in reality, capacitors are usually either in microfarads or nanofarads or even picofarads. Remember that microfarads basically means times 10 to the power of minus 6 farads. Nanofarads is 10 to the power of minus 9 farads. And picofarads is 10 to the power minus 12 farads. All right? يعني the value here, for example, if we say this is 1 microfarad, this is 1 times 10 to the negative 6 farads. 1 nanofarad, 1 times 10 to the minus 9 farads. 1 picofarad is 1 times 10 to the minus 12 farads. All right, so these three you definitely need to know, your micro, your nano, and your pico when it comes to capacitors. لأن هني شو السؤال قاعد يقول؟ يبقى in pico farads. How do you do this? The easiest way to do this is using your calculator. زين؟ في الكالكوليتر الحين أنا if I got my answer, if you guys also want to do the same, find the answer, it was whatever this value is. It gave me times 10 to the power minus 11. There is a way to do it mathematically to get this 10 to the power minus 12, بس ما أبي أضيعكم with the mathematical way. I also till today prefer using the calculator. So you're going to see a button that says ENG. زين هو تحت يعني فوق الرقم 8. زين your number 8 is going to be over here, right? But we want to look at this button ENG. When you click on this button ENG one time, when you click on it, it is going to automatically give you the next triple digit. يعني it's going to do 10 to the power minus 12. And then it will give you the value of it with 10 to the power minus 12. In my case, it gave me 24.35 times 10 to the minus 12. All right. So make sure you use this button when you want to do your transformations or your changing. ففي هالحالة it gave it in picofarads. What if I wanted it in microfarads now? زين. So remember to use this engineering button. This is so that you can go from مثلا 10 minus 11 to 10 minus 12, and then it will automatically, if you click it again, it will take you to 10 minus 15, and then it will give you to 10 minus 18, and so on and so forth. All right, this is the whole point of this button. But what if you wanted to go the other way? What if you wanted to, يعني for example, let's say example question says in nanofarads. All right, not in pico. Pico is 10 negative 12. Nice. بس احنا we want it in nano. يعني we want it in 10 minus 9. Second. We want it in 10 minus 9. What are you going to do? You're going to do the exact same thing we did here, but you are going to just hit shift before. So it's going to be shift plus inch. All right. يعني you're going to hit shift inch, shift inch, shift inch, and you're going to see the value is going to change. So C will be given as, if I find my answer, I hit shift inch, it will give me 0.024, and we want it in 2 decimal place, times 10 to the negative 9. In other words, this is in farads. Sorry, this is in farads, huh? In other words, this is 0.024 microfarads. And in this case here, this is 24.35 picofarads. Is this clear? لأن this is a very important thing that no one will ever teach you بصراحة. زين بس أنا I have found this يعني discovered this on my own a long time ago, and it's just I use it all the time when I am trying to find my values. يعني here in this case it is going to go from 10 to the minus 11 to 10 to the minus 9 to 10 to the minus 6 and so on and so forth. All right. بعد مرة بقول هني when you have capacitance, all right, if it's given to you in 10 to the negative 11 or 10 to the negative 10, okay, احنا نبغى نطلعه هني في السؤال قال نبغى نطلعه in picofarads. Picofarads means times 10 to the negative 12 farad. All right, 1 pico is 10 minus 12. This you guys need to memorize by heart. خلاص, you guys are engineers. Micro, milli, nano, pico, all of that has to be up to pico. You guys have to already know what this means. تمام, خاصة in electrical, if you're going into an electrical field. All right, so micro is 10 minus 6, nano is 10 minus 9, and pico is 10 minus 12. بس احنا جوابنا طلع 10 minus 11. كيف نقدر نحوله ل 10 minus 12? Very simply في الكالكوليتر. This is going to be your answer, صح? But once you find your answer, you can get your calculator and just hit the ENG button. When you hit the ENG button, it will automatically take it to the next closest value in من ناحية الملي والمايكرو والنانو والبيكو. In this case, 10 negative 12. If you hit it again, it will take you to the next value. If you hit it again, it will keep on going and going and going. And if you want to do the opposite, إذا تبون تروحون لأقل وأقل وأقل, يعني من 10 minus 11, you want to go 10 minus 9, which is nano, and 10 minus 6, sorry, this is nano, not micro. And then, and 10 minus 6, which is micro, you're going to hit shift, and then you're going to hit your end button, and it will take you in the other way. So this is the whole idea. Just make sure you take advantage of this in the exam. This was the first part, which is finding in picofarads. So this is our answer over here, 24.35 picofarads. The energy stored in the capacitor will be Nj. What does Nj mean? Nj, energy is in joules. So energy is equal in joules, whatever the value is. So we're going to eventually, when we find our value, we're going to have to get it in 10 minus 9 joules because we want it in nano joules. This is what the N represents, nano. All right. And the equation of energy is very simply E is equal to half CV squared. So E is equal to half CV squared. We have found our value for C. Keep in mind your value for C should be in farads when you are using in calculations. Okay. Never keep it in pico. Never keep it in nano. Tamam? So it is going to be half 2.43 times 10 to the negative 11 times V squared. Our voltage was given in the question as 20 volts, so it's going to be 20 squared. تحطونه في الكالكوليتر E is going to be equal to, so this times 20 squared divided by 2. This will give me 4.8697 times 10 to the minus 9. It already gave it to me in 10 to the power minus 9 joules. فمعناته this is equal to, rounding to 2 decimal places, 4.87 nano joules. And this is the value for my energy. The reason I took my time with this question is I wanted to explain the units, لأن the units is the most important thing when it comes to calculations. الكالكوليشن نفسه مو بصعب، الunits اللي بيضيعكم. تمام؟ So make sure your units should be correct, straightforward, you're using it correctly, you're applying it properly. ليش حطيت minus 11؟ لأن we got our value of capacitance هني. بتحطونه in farads، ما بتحطونه بالبيكو، ما بتحطونه بالنانو، بتحطونه بالجواب اللي طلع لكم في الكالكوليتر في البداية اللي هو the value in farads. ف 2.43 times 10 to the minus 11 هذا الجواب اللي طلع لي في الكالكوليتر يوم سويت هذه الحسبة. فبس عوضت هذا السي هني. تمام؟ انزين. Let's move on to the next question. A capacitor consists of two similar square aluminum plates, each 15 centimeter by 10 centimeter mounted parallel and opposite to each other. Before I even move on, شو معناتها هاي؟ زين. أحلى شيء في السؤال it said square but it gave you the dimensions of a rectangle. Just ignore that. زين. So it's a rectangle, aluminum plates. What does this mean? This gives you the area. So your area is equal to 15 centimeters times 10 centimeters. Before you do the multiplication, حولوهم إلى meters. فهاي 0.15 meter ضرب 0.1 meter. عشان بعدين ما تسوون long area شو يسمونه unit conversion. فمعناته الحين directly area is going to be 0.15 times 0.1, which is 0.015 meters squared. Okay, so this is our area. Again, make sure you convert your units into standard units اللي هو في هالحالة meters. What is their capacitance when the distance between them is 1.5 centimeters? So for part A, distance is equal 1.5 centimeters, معناته 0.015 meters. Okay, again, convert it into meters. They want us to find the capacitance, and they said our dielectric is air. ER for air is 1.006. 1.006 ولا 1.0006. زين يعني 1.0006. Okay, now you have everything, and obviously permittivity of free space they have already given it to you over here. E0, you will always have this given, is 8.854 times 10 to the negative 12. So what is your equation? C is equal to E0 ER area over diameter or distance. الميكانيكال ضرب مخي كله اقول diameter. انزين E0 ERA over distance. E0 is 8.854 times 10 to the minus 12 times ER is 1.0006 times the area, which is 0.015 divided by your distance which is 0.015. تمام. Plug this all into the calculator for 8.854 times 10 to the power minus 12 times 1.0006 times 0.015 divided by 0.015. I could have just cancelled those بس ما عليه. بيعطيكم 8.859 times 10 to the negative 12, or depending on the question what it asks. The question was saying in picofarad, so I'm just going to bring this also here. ففي السؤال it was saying they want it in picofarad, we already have it in 10 to the minus 12 and this is in farads, فمعناته 2 decimal places 8.86. تمام. 8.86 farads, picofarads, and that's it. That's your first part. The second part says if the capacitor has a given charge. What does charge mean? Charge of 600 picocoulombs. يعني for part B, Q is equal to 600 picocoulombs, or in other words, 600 times 10 to the negative 12 coulombs. All right? What will be the difference of potential between the plates? يعني, what's difference of potential? Difference of potential is voltage. Potential difference. What's your voltage? Here you will be applying C is equal to, or Q equal CV. زين, or in other words, V is equal to Q over C, which is 600 times 10 to the negative 12 coulombs over, again, it's better to keep it all in standard units عشان ما تضيعون, over 8.859 times 10 to the negative 12 farads. Okay, and usually the coulomb and farads are يعني في coulombs and capacitance الvalues مالهم بيكونون in the same يعني 10th power. All right, so V is equal to, you can technically just cancel these two لأن the number is the same number. So 600 divided by 8.859, I get 67.7 to 67.725. I'll be in 2 decimal places, 67.73 volts. Okay. The last part, very basic, just apply equation V equal Q over C. تمام. The last one says, what is the new capacitance of the How will this be affected if the space between the plates is filled with wax which has this relative permittivity? يعني الحين relative permittivity مالنا اتغير. All you're gonna do is, don't look at what the solution did. All you're gonna do is you're gonna write the same exact equation. So for part C, C is equal to E0 ER new. Area doesn't change and the distance will not change. For all you will change in this equation over here is your relative permittivity from 1.0006 to 4. That's it. Okay. فهني بيتغير كذي, هني بنحط 4. Okay. And then you will repeat the exact same steps that we have already done. Okay. Is this clear? Any questions about this so far? واضح؟ سهل؟ صعب؟ I'm taking my time هني لأن هني I'm making sure that you guys understand the concept of units. لأن بعدين I'm not going to cover this. I'm going to go directly في الحل حق when we're doing capacitors in series and parallel and all of that. So here you understand how to deal with units, right? You know what you have to do. Can I repeat B and Z? Remember our equation. What is capacitance? Capacitance is Q over V. Okay, you have this equation given to you in your formula sheet. Okay, capacitance is charge over voltage. So the question B says, what is the difference of potential between the two plates? Difference of potential difference معناته voltage. Okay, usually they say potential difference. أو هني قايلين the difference of potential. يبون يتفلسفون. All right, same thing. It is your voltage. So what do you need to find? You need to find your voltage V. How do you find it? They gave you Q and you have already found C. Simply V equal Q times C. That's all I did. Sorry, V equal Q over C. That's all I did. All right. بس هنا اللي سويته Q over C. I solved and I got the voltage. And that's it for part C. This is all you're going to have to do. And then you're going to find your new capacitance and the same equation. You're going to find voltage is equal to Q over C for the same value of Q given. And that's it. Okay. Let's see if there is any other questions. Okay, perfect. Before I go into a series in parallel, let's take a 5-minute break. لأن بعدها هني, I want you guys to be fully focused with me. I'm going to go through everything, RC, RL, and parallel and series, all in one shot. So let's have a break until تبون 5 minutes ولا 10 minutes? Your vote. 5 or 10-minute break? زين okay 10 إن شاء الله. We'll make it 8. زين an 8-minute break عشان we come back at 7 or 8:03. Okay? So at 8:03 شنو؟ أنا وين رحت؟ EN600 هني. Okay? So break until 8:10. تمام؟ Break until 8:10. If you have any questions, feel free to ask. I'm going to be here. زين. I might be eating, but I'll be here. يعني I'll be around. So if you have any questions about capacitors, just ask away. Guess what I'm eating? Diet food. I'm not eating shawarma. يا ليت اندومي تبوني اتسمم. مسرطن اندومي. امكم ما قالت لكم مسرطن؟ I'm eating fruit salad. That's what I'm eating. If you really want to know. زين. So what about capacitors in a circuit? Then, when we have them in a circuit, how do you combine capacitors? Capacitors are opposite of resistors when it comes to combination. For capacitors, opposite to resistors in combination. What does this mean? In parallel, let's start with in series. In series, resistors is R1 plus R2, صح? R total is equal to R1 plus R2. For capacitors, is going to be 1 over the capacitor, the total capacitance or equivalent capacitance, is 1 over C1 plus 1 over C2. And then basically the parallel rule of resistors. And for two capacitors, you can use the same shortcut, which is CT is equal to C1 times C2 over C1 plus C2. Remember, this is only for only two capacitors. And then in parallel, resistance is equal to R1, R2 over R1 plus R2. Capacitors is going to be just C1 plus C2. Opposite. يعني basically the same way as resistors in series. But when you see two capacitors in parallel, you're going to use this rule. You're just going to add them up. And if they're in series, you're going to be doing the multiplication and then divide by C1 plus C2, or 1 over C total is 1 over C1 plus 1 over C2 plus 1 over C3 if you have more than two resistors. So if we want to reduce this, all right, this first one over here is going to be C45, all right? C45 is equal to, are these in series or parallel? You guys tell me. Yalla, at this point, you guys need to know if these two are connected in series or in parallel. Are these two in series or are they in parallel? Remember the rule of connections. بعض الناس كتبوا الله أعلم شو بالعربي، بس شكله parallel كاتبينه بالعربي. بعض الناس قالوا parallel، بعضهم أكثركم قلتوا series. This is series. This is because you have one connection point. When you have one point of connection, معناته series. They're only connected at one point. And the bottom over here, they're not connected to each other. They're connected to something else. So they are only connected at one point. معناته they are in series. You guys should know this by now. All right. For C4 times C5 over C4 plus C5. This is what you will get. All right. This is how you do the reduction, and you will do the same for the remaining ones. So now we have, let me actually just do this 1 second. عشان ما تتخربطون. I'm just going to do it for the first two عشان you guys get the general idea. So now here you have this as C45 connected to this. And then this is your capacitor over here. This is C45, your equivalent capacitance that we have found earlier. So now these two, are they in series or are they in parallel? It's very clear at this point because you have two connection points. You have a connection point over here and you have a connection point over here for both. So now they are connected in parallel because here is one connection and this is a second connection. So because they are in parallel, C345 is equal to C3 plus C45. And you can keep doing the reduction all the way till you reach C equivalent. All right. This is how you will apply it. We've done this a lot with resistors, the exact same method when it comes to it, but the way or the equations are opposites for series and parallel when it comes to capacitors. Let's look at the next question. So two capacitors of this capacitance, 4 microfarads, and 2 microfarads respectively, are joined in series. معناته the connection of them are like this. They are in series with a battery of EMF. EMF means voltage of the battery. And then Technically, if you're talking about a battery, the battery looks like this: positive, minus, positive, minus, positive, minus. It is a group of cells technically, and then, but it's the same thing. What they mean is it's a voltage source of 110 volts, and one of these is 4 microfarads, and the other is 2 microfarads. All right. The connections are then broken, and the like terminals of the capacitors are joined. Find the final charge on each capacitor. Let's take that step by step. So if we look at this, current flows from the positive of the source and comes back to the negative. We know this. معناته these should be connected plus over here and minus over here. زين you have to connect يعني these already are polarized بس معناته you need to make sure that your connection is in the proper way. All right, this is how you would connect it: the positive end to the positive and the negative to the negative. All right, then they said they broke it off. يعني the connection is broken مع البطارية، شلوا البطارية, and the capacitors of like terminals are joined. بما معناه الcapacitor they got joined together like this. All right, so the positive side is connected with the positive side and the negative side is connected with the negative side. Okay, so they were connected together like this. Let's say the top one is the 4 microfarads and the bottom one is our 2 microfarads. تمام. And we'll look at both. We'll first analyze the left one and then the right one. Now, 1 second. Let's خليني أطول line. Okay. So for the left side, if we're looking at this here, these are two in series. How can we find their equivalent? How can we find their equivalent? They're a series connection. So their equivalent is going to be one capacitor. So let's call it C equivalent. It's going to be 4 times 2 over 4 plus 2. When it comes to units, if you're only dealing with capacitance directly, you can keep them all the same unit and your final answer will be the same unit. يعني هني micro, هني micro. Since they're both micro, you can keep them the same way they are and your answer will be in micro. All right, so when it comes to unit, just make sure of that. So it's equal to, and you can change it back and back if you want, but there's no point. You'll be wasting time. 4 times 2, that is 8 over 6, which is 4 over 3. زين يعني 1.33 microfarads. All right, so this is the capacitance. It is 1.33 microfarads. All right, this is our equivalent. Why? Remember, voltage is the same thing. The voltage works the same way in any circuit. Voltage here, since they are in series, يعني voltage is split between these two. All right. However, the charge of each is equal. معناته our Q value هني are equal. Q1 equal Q2. Q1 equal Q2 equal to Q. All right. So our charge for a series connection does not change. يعني the charge going through here is equal to the charge that we have over here. This is the rule for charge when it comes to series connections. All right. This isn't equal to Q total. Keep that in mind. That is different. Okay. This isn't like current where I total is equal to I1 equal I2. لا. And here we're just saying that the charge for this capacitor is equal to the charge of this capacitor. That's all we are saying. Okay. Now, if you want to find your Q, then before even that, if you want to find your total Q, Q total is going to be equal to Q1 plus Q2, or in other words, it is equal to Q plus Q, and it is 2 times Q. Okay. This is how it is when it comes to a series connection. معناته your total Q is equal to the Q of this plus the Q of that, and the value of the Q, the value of your charge, is equal for each capacitor. Okay, how do you find the charge of the capacitor? Very simple. Q is equal to capacitance over voltage total. So capacitance total or equivalent over the total voltage, or in other words, it is 1.33 over the voltage total, which is 110. معناته our Q. Tell me what I did wrong here. شو الغلطة اللي سويتها هني؟ I put 1.33 but this is micro. معناته I need to multiply by 10 to the negative 6. Okay, so 1.33 times 10 to the negative 6 over 110, which is going to be equal to Q is going to be equal to 146.67 times 10 to the minus 6 coulombs, or you can say it's equal to 146.67 micro coulombs. Okay, so again I will repeat this concept. يوم انتوا عندكم two capacitors in series. Okay, يوم يكون عندكم two capacitor in series, the Q, the charge that is flowing through each capacitor, is gonna be oh صح, my bad, this is gonna be Q equals CV. I did not copy the equation correctly. يعني Q is equal to CV, which is C total, C equivalent times V total, which is 1.33 times 10 minus 6 times the total voltage 110. Sorry about that. Thank you, Elias. And then again, I will repeat the concept. هني, when you have two capacitors connected in series, the charge that is flowing through the capacitors is equal. يعني the charge through this capacitor is equal to the charge that is flowing through this capacitor. But that does not mean this is the total charge. The total charge is this plus this. يعني the charge of this capacitor plus the charge of this capacitor. But even though they are equal, that's why we find our Q by doing our C equivalent, our total capacitance, times our voltage total to find the value of our Q. This again is not our Q total. What is our Q total? Q total is equal to 2Q in this case, which is equal to, or if I want to say this better, that is equal to Q1 plus Q2 معناته 146.67 plus 146.67 معناته Q total is equal to 293.33 micro coulombs. All right. And you will see in a bit why I am finding our Q total, but you guys need to understand for a series circuit. Then, 1 second. For a series circuit, عندكم الcapacitance for the capacitors. Then they're gonna have this rule to find their equivalent, and the charge that is going through each one is gonna be the same value. يعني the Q that is going through each is gonna be the same. However, when you want to find total capacitance, you are going to first find the one capacitance for one capacitor, which is using C equivalent times the total voltage to find your capacitance for one. And then if you want to find your total charge, you're going to add your two charges together to get your total charge. So why are we finding the total charge in this case? Because we are going to be using it when we want to apply it over here in this rule. Okay, so again, here we have done our analysis. We managed to find our total charge for this side for series and this case. But what happens when we remove the voltage supply and then connect these two together? These now are connected, if you notice, in parallel, because we have 2 points where they are connected, if you think about it. Okay, you have 2 points where they are connected together. معناته our rule for C equivalent now is equal to 4 plus 2, which is 6 microfarads, because this is a parallel connection. Parallel connection. Okay, in a parallel connection, your Q is not the same at all. The Q will now be different, which is your charge. Then the charge going here, there is no specific rule for charge. However, what do we know about a parallel connection? V1 equal V2 equal V. The voltage across both of these is now equal. لأن they're connected in parallel. We know that voltage is the same for a parallel connection. Okay? How can we find our Q in this case? Using the exact same equation. Since the voltage is the same for both, we can find Q. For example, let's say Q1 is going to be equal to C1 times V, and Q2 is going to be equal to C2 times the voltage V. Okay? So Q1 is going to be equal to C1V and Q2 is going to be C2V. Why just V? لأن V is the same for both. So this is in the case of parallel now. All right, when two capacitors are connected in parallel. But how can we find this voltage? This is the reason we find the C equivalent, because we already have the total charge that we have found earlier from a series circuit. The total charge will not change, meaning that Q total is equal to C equivalent times the voltage. Since we have C equivalent and the Q total, الفولتج بيكون Q total على C equivalent. تمام? Voltage is not changing in a parallel circuit. Voltage is not changing in a parallel circuit. So for when it comes to Q total that we have determined from our series circuit, we can use that Q total now to find the total voltage that is being applied here by the capacitors on each other. Then they have stored capacitance now. La? This is where we have found why we have found our total Q. Once we find our total, now that we can find our voltage simply as the QT that we have found earlier, which is 293.33 times 10 to the negative 6 coulombs over our C equivalent that we have found for the parallel, which is 6 times 10 to the minus 6 farads, meaning our voltage V is going to be equal to 48.89 volts. Is this clear? فاهمين أنا شو سويت هني؟ بعيد بعد من البداية from the very beginning. لأن this concept you understand it, you can apply it to any circuit. When you have two capacitors in series, so in this case on the left side we have a series capacitance. We already understand how to get C equivalent. حلو. We know that voltage is not equal. We know that from before, that voltage in series is not the same. Okay, nice. But what rule do we know now? What's the new rule that we need to know? And the capacitance of 1 and 2, Q1 and Q2, are going to be equal in a series. Mob capacitance, the charge, Q, is going to be equal for a series circuit. When they're connected in series, the charge across here is equal to the charge across here. Tamam? So we can find the Q, the charge, by finding our total equivalent capacitance, because it will also have a specific, the same equivalent charge, which is doing this, Q equal C equivalent times the total voltage. Once we find our total charge, or I should say our equivalent charge, we need to find now the total charge that is being stored. This one is storing charge and this one is also storing charge. فمعناتها this charge plus this charge is the total stored charge. That's why we are adding Q1 and Q2 to find our Q total. Keep in mind Q total is not equal to C equivalent times VT. Q of each capacitor is equal to C equivalent times VT in the case of a series circuit. So once we find the total charge that has been stored by adding them up, we can use this in our parallel circuit if they are reconnected. هني يوم قاعدين يستوون reconnected. Now basically one of them is acting as a battery for the other. زين يعني one of them is discharging into the other one basically. This is what's happening. Okay? So when we find our equivalent capacitor in a parallel circuit is just addition. Q1 we can find it now. Q1, let's say that this is Q1 for the 4 ohm, and Q2 is for our 4 farads, 4 microfarads, and our Q2 is for our 2 microfarads. We just apply our CV equation. Since this is a parallel circuit, the voltage across both, because they're between the same nodes, the voltage across this capacitor is equal to the voltage across this capacitor, meaning that our total voltage is also the same. Now we can find our total charge that we have found from series. We can use it, I should say, with the equivalence capacitance that we have found of the circuit to find the total voltage, which is the same. Once we find this total voltage, now we can apply it to find our Q1 is equal to C1V. معناته capacitor 1 is 4 times 10 to the minus 6 times the voltage that we have found, which is 48.89, and Q2 is equal to C2 times V, which is equal to 2 times 10 to the negative 6 times 48.89. And we have found what the question wanted, which is the final charge on each capacitor. Any questions about this? I didn't get the Q part. Again, the idea of Q هني زين when we have a series connection. احنا الحين الكاباسيترز we are charging them صح؟ البطارية هاي it is charging the capacitors. The charging it is charging both is equal, of equal value. Different voltage, but the charge is going to be of equal value. يعني this one will get Q amount of charge and this one will get a Q amount of charge. زين? Both of them will have the same amount of charge when it comes to charging. So what we need to find is we need to find our total equivalent resistance, or equivalent, I should say, capacitance, عشان we can find what this charge is coming out of this battery. So you can think of it as there is a specific Q that is going into both of these. This Q is not changing, same as current. If you remember current, does not change. Okay, the current does not change. Once you find the equivalent, the current will stay the same. Same concept here. So the Q will stay the same. The only difference is this is the Q for each capacitor. All right. So the charging of each capacitor is the same. And this charging, we can find it using C times V. In this case, we're finding the equivalent because we do not have, we have a series circuit, we do not have the voltage across each one. So we need to find the equivalent, which will also have the same charge flowing through it, times the voltage over here. And using this equation, CV. يوم نطلع الحين هالQ, this Q is the same Q that is going through this capacitor and this capacitor. But if we want to find the total Q of both capacitors, the total charging that has occurred, we have the charging that occurred for this plus the charging that occurred for this capacitor. معناته عندنا الشارج اللي صار هني زائد الشارج اللي صار هني وبنحصل هذا التوتال charge that got stored in both capacitors. Therefore, we did Q1 plus Q2 أو بما معناه Q plus Q. لأن we have two capacitors here and here. This gave us our Q total that we have found down here. Q1 plus Q2. Once we find this Q total, why are we even finding it? Because we want to know what the total charge right now is in this circuit over here. To find out what our voltage is when there is no voltage source, the voltage of the capacitors themselves. This is what you're trying to find. لأن they are connected in parallel, the voltage is the same. This is V1 and this is V2, and they are both equal to V. They are equal to each other. They are all equal because it's a parallel circuit. فنقدر نطلع التوتال الفولتج من التوتال charge that we have discussed or have found in the previous scenario when they were in series. لأن الcharge came from the battery. الcharging يوم تشارجون الشيء يجي من بطارية، البطارية اللي قاعدة تشارج both capacitors. فتشارجهم اثنيناتهم مع نفس المبلغ مال الشارج، نفس المبلغ لأن البطارية قاعدة تطلع نفس المبلغ من current. Remember Q equal IT. زين يعني Q is related to current. It's related to the current. Okay? This is the original rule of current if you remember from before. فمعناته it is coming with the current. فif this current value is the same here, the Q is going to be the same here, well the Q is going to be the same here. بس احنا when we're talking about the total capacitance or the total charge, احنا we're considering each one by itself and we're adding them together. For the Q over here plus the Q over here. This total is the same total charge that is stored in both of these. The same charge. خلاص, it's stored in them. So the total charge QT here is the same as the total charge QT over here. نفس التوتال charge اللي عندنا إياه. تمام؟ يعني إذا عندكم تلفوناتكم، واحد عنده تلفونه والثاني عنده تلفون ثاني بطاريته شوي غير. البطارية هني تشرجت لفل وهني البطارية بعد تشرجت لفل. نفس الشارج بيكون يوم تشيلون هالتلفونين تودونهم أي مكان ثاني، نفس الشارج بيكون عندهم لين ما يفضون. لين ما يفضون بيكونون نفس الشارج لأن شرجتوهم نفس الوقت. تمام؟ نفس الطاقة نفس كل شيء نفس الشارج بيكون فيها. ف when you connect them here, both mobiles, you can say, or capacitors, they have the same charge, the same total charge, I should say. ولكن each one specifically على حسب مثلا استخدام التليفون تقدرون تقولون، لأن هاي بطاريته أقوى هاي بطاريته أضعف أو whatever. الديسشارجنج يعني Q1 بيكون غير عن الستور charge of Q2 in this scenario، لأن now you have connected them to each other. ف there is discharging that is occurring، يعني واحد منهم قاعد يتشارج ماله يفضي. تمام؟ But we still know that the total charge is still the same. So we know that we can find QT equal equivalent times the total voltage. نقدر نطبق هالقانون حق equivalent مال these two capacitors. When you apply that, you can find your voltage, and then using the voltage, since it is a parallel circuit, so the voltage is the same here and here, you can find your Q1 and you can find your Q2. Let's do another example so you guys can get a better idea of how this will work. Let's look at it here. Then, so 3 capacitors A, B, and C have capacitances 5, 50, and 15 respectively. All right. The supply voltage is 300 volts. معناته عندكم these two وين شو السؤال أصلا؟ when the charge is on لا انزين أنا بحط لكم السؤال. فعندكم these two circuits, one of them where they are connected in series and one of them where they are connected in parallel. Okay, remember this is basically the same as drawing them like this. يعني this is as if you're drawing them like this. It's the same thing. Okay, they're in parallel. How do you know they're in parallel? Just apply the rule. They're all connected at 2 points to each other, so they are in parallel. All right, so you have your capacitors here and you have them then connected in this formation. فأول شيء 3 capacitors, they have these capacitances. So this is 5 microfarads. This is 50 and 15. والvoltage for both هني عطوكم voltage source was 300 volts صح 300 ايه هني بعد 300 volts. So now they're no longer connected directly to each other. So let's analyze each one by itself. So here we have 5 microfarads and we have here 50 microfarads. Well, here we have 15 microfarads. If we look at the first one over here, let's analyze the series one first. Like I said earlier, since we are in series, we have these rules that we can apply. C equivalent is going to be, in this case, since we have 3 in parallel, we're going to have to use the longer equation, which is 1 over CT, or C equivalent, is equal to 1 over C1 plus 1 over C2 plus 1 over C3. هذا أول شيء. ثاني شيء نعرف ان V total equal V1 plus V2 plus V3. لأن there is a series connection. لا, we know that you have to add up the voltages to get your total voltage. All right, not important this rule at all, but this is from before, from resistors. And we know that Q is equal to Q1 equal to Q2 equal to Q3. All right, remember this is Q and not Q total. Q total is equal to Q1 plus Q2 plus Q3, or in other words, it is going to be 3 times Q, لأن these are all equal to each other. Alright, in this case يعني, in this scenario. وبعدين نقدر نطبق أي قانون عشان نحصل anything they want. So I believe the question is, find the charge on each capacitor for each one. How do you find the charge? Remember that charge is equal to C times V. But here, the first thing we need to do is, let me copy paste this down. The first thing that we're going to need to do is, we're going to need to find our equivalent. We need to find our C equivalent. So C equivalent is equal to, C equivalent is equal to, or 1 over 5 plus 1 over 50 plus 1 over 15. All right, it's just this rule I am applying, and I just divided by 1 from the beginning. For C equivalent that we get is going to be, I think I already calculated this from before. It is 3.49 microfarads. Okay, this is our C total. And now how am I going to find the charge for each one over here? The charge for C1, C2, C3. Simply, charge is going to be C equivalent times our V total, our V source or whatever. So our V source is 300, C equivalent is 3.49, so it's 3.49 times 10 to the minus 6 into Vs, which is 300. You will get Q is equal to 1046.51 microcoulombs. All right. Yani once you do all of the calculations, you will get it in microcoulombs. This is what it will be. Okay. Now that we have found Q, the charge across each and every one of them is the same Q. But what if I say, what is the voltage across each one of them? How are you going to find it? V1, remember that Q is going to be equal to C1 V1. معناته V1 is going to be equal to Q over C1. And we are going to be applying the same rule for each capacitor. V2 is equal to Q over C1. And the charge here is not changing. The charge is the same for all of them over C2. And then Q equals C3 V3. معناته V3, the voltage across the third capacitor, is Q over C3. So this is going to be equal to the Q that we have found, which is 1046.51 times 10 minus 6 over C1, which was 5 microfarads, so 5 times 10 minus 6. Same thing for the next one, same thing for the one after. This one's going to be divided by 50 times 10 minus 6, and this one's going to be divided by 15 times 10 minus 6, and the top is always going to be the same Q value. All right. So this is how you would be using Q in series. The Q does not change. It is the same, very similar to current in series. All right. Very similar to current in series. In parallel, now if we look at this, what are the rules that we have? Let's first write down the rules. So parallel, زين, عندكم 1 over, عندكم C total is simply C1 plus C2 plus C3. V total is equal to V1, which is equal to V2, which is equal to V3, which we'll all call just V. معناته this 300 volts is for all of them. All of them has 300 volts as a potential difference. Okay? And Q is now no longer equal to each other. But what is Q equal to? Very simply, Q1 is going to be equal to V1 or V times C, يعني C1 C1 times V. Q2 is going to be equal to C2 times V. Q3 is going to be equal to C3 times V. And that's it. That's the only difference. This is what you guys need to understand mainly. And now the Q over here is the same for all of them. In this case, Q is not the same, similar to current. Remember in current, when we do V equal IR for each one to find the current. We know voltage is the same, and we have the value of the resistances. Very similar concept here, but with capacitance. So our charge is going to be different for each one, but the voltage is the same across each and every one. So if we look at this now, if we want to solve it very directly, so for Q1 it is equal to C1V. معناته 5 times 10 to the minus 6 times our voltage of 300. زين Q2 is equal to C2V. 50 times 10 minus 6 times the voltage of 300. The voltage will not change. And then Q3 equal C3 times V, which is 15 times 10 negative 6 times 300. Okay? And that's it. And if you want to, if the question asks for C total, it's just C1 plus C2 plus C3. معناته 5 plus 50 plus 15, which is equal to 70 microfarads. Okay. Q is exactly, not exactly, it is very similar to current and resistance. Yes, you will use it as if you are looking at current and resistance. When you're dealing with resistors only. You know, when current and resistors, when you look at it, you say that current changes in parallel circuits, but it's the same in series circuit. That is completely correct. Just keep in mind one thing in series circuit. Q total is not equal to Q. Also, Q total is not equal to Q equivalent. زين? But Q equivalent is equal to Q. This is a very important thing to understand. لأن انتوا يوم you're talking about total charge, you're going to be adding up the charge of each value. يعني Q total is equal to Q plus Q plus Q. This is the difference. تمام? Q equivalent is not the same as Q total. Q total is just this equation. You're not going to be using Q total from anywhere from series circuit. However, Q total in parallel circuit, Q total is equal to C equivalent times the voltage for parallel circuits. Okay, your Q total in parallel is equal to the C equivalent times your voltage, or V total, but it's parallel, they're all the same voltage. Because here, now our voltage is the same across all of them. So the charge that is charged on all of these that have the same charge is going to be Q total from this equation. Clear? But in parallel, you do not use this equation. You cannot say Q2 total is equal to Q plus Q plus Q because you'd have different values of Q over there. Clear? Let's look at another example if there is any. Okay. There is this example. I'm just going to go do very quickly through it. I'm just going to explain the thing. I'm not going to go in details. عشان at least I can start with what's it called? RC circuits. All you're going to do here is you're going to find the equivalent of this, and then you're going to get a circuit like this. All right. And you're going to deal here, you're going to deal with the parallel rules for this circuit. And for this circuit, you're going to be dealing with series rules. And that's it. That's it. All right. So here you have Q2 and Q3. All right. You have Q2 and Q3. They're different than each other. But remember, Q1 is going to be equal to Q2, Q total from over here. All right. Or actually, the better way of doing this is, remember, this is C23. All right. So this is C23. The Q over here that you are going to find, let's call this just simply Q. Q1 is equal to Q23. All right. Again, you're going to be finding the charge and all of that using the parallel rules and the series rules that we have applied from before. Most of the time, this is what they're going to be asking. They're going to be asking you to find charge, or very rarely they're going to give you charge and tell you to find. Because what will be always given in the circuit, it's same as current. Remember before, they will always tell you find current. They never give you current. Same exact idea. You always know your voltage source and you always know your capacitance values. Everything else is unknown, and that's what you need to find. Similar to before. Let us move on to the next concept, so at least you guys have a general idea of what an RC circuit is as well. So when we're talking about an RC circuit, what do we mean? We mean a resistor and capacitor circuit. معناته بيكون عندنا plus minus, عندنا a capacitor over here, and we have a resistor with it in series over here, and this is your basic RC circuit. But how does this RC circuit work? Remember what I told you early on. This is going to be plus, plus, minus, minus. And then, remember what I told you early on. So this over here, we're going to call this the voltage total. This we're going to call voltage of the capacitor, and this we're going to call voltage of the resistor. Since they're connected in series, voltage total is equal to voltage of the capacitor plus the voltage of the resistor. Okay? Very simply, this is the case. But this isn't what we need to look at. If you want to rearrange this is going to be Q over C. صح ولا لا؟ لأن VC is equal to Q over C plus IR. This is what our V total is. لأن here we are talking about the current flowing, and here we are talking about the charge flowing over the capacitor. All right? V equal IR and V equal Q over C for each one. As what you guys need to know about RC circuits is three major things. And I'm going to explain these using graphs because that's the best way. The idea of this RC circuit, again, we're looking at the charging capacity of this voltage source over here, or of this capacitor over here. So when we're talking about charging, let's make a graph of time with the capacitor voltage. زين يعني VC. At the very beginning, let's say that there is a switch over here, and it was open. Okay? Let's just say hypothetically the switch is open. As soon as this switch is closed, when you close the switch, at the very beginning before even closing it, this capacitor has zero charge in it. يعني ما في ولا voltage صح? At time zero, it starts from nothing. It has no capacity, it has no charge, nothing, no Q, no value at the very beginning of this. Once you close the circuit, the charge value of it keeps increasing exponentially until it becomes fully charged. All right? So until it becomes fully charged. And if you notice, this is the shape of an exponential curve. All right? And what is this value over here? This is the value of V or VT, V total. This is the value of our V total over here. And now when the charging, what does charging basically do? It makes sure that this reaches the full voltage possible from the battery. And this, by the way, happens in milliseconds, if not even less. All right? Yani this happens very quickly in real case scenarios. Yani usually the time given is going to be very short. Okay? So in this time, it starts from time zero, until it reaches something known as, this is what they call the steady state, and you will see a lot of this later on in your future years in engineering. This is known as your steady state region. بما معناه when your value has become straight line, this is your steady state region. يعني when VT equal or VC equal your VT, your voltage total from the battery. This is your steady state region, and this region over here is known as the transient region. بما معناه ان here this is changing or transitioning from being uncharged to يعني fully charged. Alright? So this is your transient region. تمام? And there is a known value, it's a constant known as your time constant. This time constant is basically a linear value if you draw a line from here that is going straight like this over here. All right. I'm not going to go into details for the theory. I just need you guys to know what it is. It basically, this is the value of your time constant over here. It's a value of time. So this is the point of your time constant over here. And it is when basically the capacitor is charged at 63.2%. You don't need to know this in detail. You're going to see this a lot later on in later years. But what you need to understand is what this time constant represents. This time constant tau, in the case of an RC circuit, is equal to C times R, which is capacitance times the resistor. So the value of the capacitor times the resistance. I'm not going to show you the derivation of this for now. I just need you guys to know what it means. This value of tau basically describes how fast the system is getting charged. يعني how fast is it reaching the steady state region from a transient region. يعني how fast will this go from here to here. ليش؟ لأن الحين if we had a larger tau value معناته let's say here we'll call this tau 1. This basically means that our curve looks something more like this. زين. So it basically took a bit more time for it to reach the 63% capacity rate. يعني when tau is large or larger, خلينا أسوي بس arrow up, معناته it will take longer time to charge. All right, this is what this constant represents. زين? And let's say if it was smaller, يعني let's say if our tau 2 over here, let's say it was from here, the curve is going to look something like this from up here. Actually a bit less زين, it's going to look something more up, tau 2 is going to look something a bit more like this. يعني it's going to reach faster, يعني it's going to charge faster. So when tau is less, يوم التايم يكون أقل, a time constant, it reaches the 63.2% faster. Okay? معناته shorter time to charge. Okay, so basically this is the entire idea of an RC circuit when you're looking at this curve. And one more important point, once you reach your steady state region, once this capacitor is fully charged, خلاص, no more current will be going through the circuit, معناتها it will turn into an open circuit. So when fully charged capacitor, this is what you will get. You will get your battery over here, and this will be as if it is an open circuit. Then open circuit. This is what happens. It becomes an open circuit. معناته the value of this VR doesn't exist anymore. So VR becomes equal 0 because I is equal to 0. تمام? So this is what happens when a capacitor becomes fully charged. Hence, you guys are only going to be using these equations, which is basically describing the graph. زين. These equations over here, which is the growth of the capacitor, which is V, this is given to you in the exam, V 1 minus E minus T over tau. زين. So this is V 1 minus E minus T over tau. Okay. This is your VC. بما معناه this is your charging rate. Your charging voltage. Okay. لأن this keeps increasing exponentially at this using this equation. And this equation is simply just the equation of the curve. All right. This is what this equation represents. That's all it is. And then, like I said, as you are charging your capacitor more, the voltage of the resistor is going to go down. Why? Because the more you are charging your capacitor, the higher the value of Q, صح? So معناته VC is going to go up. Our V total is a constant. It does not change. It is the voltage of the battery. So as your VC is going up, your charge is going up, your VR is going to be going down. IR is going to be going down. So this will keep increasing charge and this will keep decreasing in terms of voltage. Yani more voltage will be given to this capacitor until this capacitor's voltage is exactly equal to the voltage total or being supplied. معناته this resistor is going to be basically useless. Yani there's no voltage going through it, in other words. All right. Yani this VR is going to be equal to 0. So that's why and the decay of the resistor voltage is given by this equation, which is VR is equal to VE minus T over tau. Graphically, all right, graphically, the curve is looking like this, where this is VR, and this is, and it reaches 0 eventually, and this is your time. And the last equation, which is for your current of your resistor as well, the current of the resistor. Same exact idea as the voltage. It starts with full current going through it. Then at the very starting point, we said we have no charge going across VC. So the current here is going to be at highest. Yani there is not going to be a Q value. Then the resistor is a constant, but current is not. The current is what's changing, what's reducing your VR. So here current is going to be highest, meaning that this current over here is IR initially, but over time it is going to go all the way to 0, and this equation is IE minus T over tau of this curve. So if we apply this in a question, it is very simple, very straightforward. All you're going to have to do is just plug in values, and I'm going to show you how. So a circuit consists of a resistor connected in series with a 0.4 mu capacitor and has a time constant of 14 milliseconds. So our capacitor C equals 0.4 microfarads, which is equal to 0.4 times 10 to the negative 6 farads. Remember to always change the signs. And your time constant tau is equal to 14 milliseconds, meaning this is 0.014 seconds. Determine the value of your resistor. Tau is equal to C times R. معناته from tau equals C times R, you can find that your C is given, you have C, your R is tau over C, which is simply 0.014 divided by 0.4 times 10 to the negative 6. And you will notice you're going to get a very large number over here. So 0.014 divided by 0.4 times 10 power minus 6, you get 35,000 ohms, or in other words, 35 kilo ohms. All right. And now they're asking to find the capacitor voltage. So VC, we need to find that after connecting the circuit to a 10 volt, 11 milliseconds after. So our time is equal to 11 milliseconds, or in other words, 0.011 صح? Yep, seconds. After connecting the circuit to a voltage V of 10 volts. تمام? If we look at our equation over here, this is the equation that we used. VC is equal to V1 minus exponential minus T over tau. معناته, what is our voltage? This is the voltage supplied, 10 volts. This is the voltage supplied voltage. Times 1 minus e to the power, what is the time given? Minus 0.011. Divided by what was our time constant? 14 milliseconds, or 0.014. And that's it. And you find your VC. And this is how almost all the questions will be. But maybe instead of they're asking the charging of the capacitor, they might say the discharging or the decaying of the resistor. And you can use the same equation that is seen in the formula sheet. So this will be minus divided by this. You will get 5.44 volts. تمام. أول خطوة time صار tau. أول خطوة هني they said time constant. Time constant is not the same as tau. Okay? Time constant معناته your tau. This isn't equal to t. This isn't the same as the time. This is a property of the circuit على حسب resistance value مالكم capacitance value اللي عندكم إياه. ف you can find tau using just this simple equation in an RC circuit, which is C times R, capacitance times resistance. And then the time itself is a different component. يعني هني the capacitor voltage 11 milliseconds after. So this is the actual time. يعني this is the time t that is being completed. تمام? Again, all you're going to have to do is just apply it to these equations and you will be able to find your values. I wanted to solve all the rest and start RL as well. Unfortunately, due to time, I will not be able to do that today. Inshallah, tomorrow I will try